This is video 2 for Unit 2, Part 1, PowerPoint lecture notes. The first learning objective we're going to take a look at is taking a look at matter in its 3 forms. Do you remember when you were in elementary school and how everyone had to line up in line to wait for their teacher? What if someone brought around Frosted Flakes, sugary cereal to all the students? Let's say you all lined up perfectly nice and neat in nice, neat little rows. What happens when you add Frosted Flakes or sugar to the mix? Everyone eats their Frosted Flakes, and then people start moving around. People start picking with each other's book bags. They start bumping each other. They start moving out of line. And then after a while, start running all over the place. What was in that cereal that made them different? Well, if we think of everyone lined up perfectly straight in those rows, we would consider that a solid. When people start moving around, doing little things, but still in line, that could be considered a liquid. But running all over the place, running around, playing tag, that's a gas. But what was the difference between them? Energy. The sugar provided the energy. So there are 3 main states of matter that we're going to discuss in this class. And they are solids, liquids, and gases. And when we change a state, it is when a substance converts from one state of matter to another. Now, please keep in mind that, let's say if I have liquid water and I freeze it into ice cubes, did it change to something other than water? No. And if I melt those ice cubes, does it change to something other than water? No, it does not, right? So these are processes that are physical processes because we do not change the composition of the substance. So changes in states are physical processes. So changing from a solid to a liquid is freezing when I'm going from a liquid to a solid, and it's melting when I'm going from a solid to a liquid. And we'll take a look at these a little bit later. So once again, what causes the substances to change state? Think again about that lineup in school. So gases are particles that are widely separated. They don't have a definite volume or shape. They spread out to take up a whole container. A liquid is a substance that has particles that are close together. They have a definite volume, but no definite shape. Let's say I take my cup of coffee here. Can you guys see the coffee? No, you can't really see coffee. Anyway, if I take my cup of coffee, it's a definite volume that's inside this cup. Now, if I spill it on the floor, it's still the same volume. It just now doesn't have a shape, right? Solids are substances where their particles are very, very close together. They have a definite shape and a definite volume, right? Many substances can exist in all 3 of these phases, and they participate in changes of state. So here are some models that we can take a look at where we can identify differences between a solid, a liquid, and a gas. Once again, these are, anytime you see these highlighted, underlined words on one of the slides that you have available to you, these are clickable, and you can click on it to go to a website. Notice here that for solids, right, they're ordered nice and neatly, they're rowed, they're highly ordered. Whereas liquids, so we look here, the liquids, they're kind of jumbled up. They're a little packed close together, but they're jumbled up. Whereas gases, these little shadows behind them are representing the fact that they're moving, right? So what causes substances to stick together in a solid, liquid, or gas? Well, that's what we call intermolecular forces. And intermolecular forces are the attractive or repulsive forces between particles, whether it's of the same substance or whether if it's between mixtures, right? So these are attractive forces that hold substances together in place. So you would imagine that there are strong attractive forces between solids, because if you run into a wall, does the wall move? No, you can't break apart the parts of the wall, right? And you might fall and bust your head, right? So, however, can you move through water? You can swim. You can swim through water. Those particles are close together, but something can move through them easily. And we can do all of this through air. And the reason why is because the particles in air or in gas molecules are so far apart that they have no intermolecular forces between them. Right. And so that's where we see here these interaction between particles, right? They're either very strong, strong, or essentially none. Can you tell the difference between this substance here versus this substance? What would we consider this? Would we consider this an element? Would we consider this an element? They both can be elements, but this looks like one of those diatomic molecules like oxygen, right? Because these are the same little spheres that are joined together. Both of these are elements. Just one is made up of two of the same atom together, those diatomic molecules. Take a moment and read through this chart, and you might want to write it down to help you memorize the difference between solids, liquids, and gases. Let's do a little bit of practice. Let's identify matter and describe their properties. Take a moment, pause the video to see if you can identify these substances. When you're ready, come back and let's get the answers. Are you ready? Okay. Number A, or letter A, it has a definite volume, but it takes the shape of the container. Is that a gas or a liquid? You're right, it's a liquid. Its particles are moving rapidly. Well, gas particles move really rapidly, and depending on how much energy there is in a liquid, it can move rapidly as well. So we can say gases or liquids, right? It all depends because they are always moving. If its particles fill an entire volume of a container, that would be a gas. Its particles have a fixed arrangement. That's those solid particles. And its particles are close together, but moving randomly. That's a liquid. I do want you to note that even in a solid, all of the particles are doing this. Can you see me moving? Can you see me? Barely, right? They're all vibrating unless we get to absolute zero, which is the coldest temperature that we have on record, right? And that is where particles do not vibrate at all. All right, let's look at these other set of questions. Identify the state of matter for each of the following. Vitamin tablets, solids. What about eye drops? You guessed it, liquids. Vegetable oil. That's a liquid as well. It's just a thick, viscous liquid. And that's because its molecules are really large and they have a lot of interaction with each other. How about a candle? A candle is a solid, although it's a soft solid. So its intermolecular forces are not as strong as, let's say, sugar molecules that are joined together in a cube of sugar, right? How about steam? You guessed it, it's a gas. Okie dokie. Let's now classify the properties of matter. And let's take a look at the difference between chemical and physical properties. So there are two types of properties of matter. We've got physical properties and we've got chemical properties. First, we're going to take a look at physical properties. And although these are just a few physical properties, size, color, temperature, these are useful for identifying substances or objects. Chemical composition and chemical reactivity, the only time we can identify or notice that the chemical properties are if a chemical reaction has occurred. Do you think we could use a measurement to identify chemical reactions? Not really, but we can use instruments to identify the physical properties of matter. We can use instruments to determine if a chemical reaction has occurred, but not to actually measure those chemical properties themselves. So physical properties are observed without changing the identity of a substance. So for example, that shape, physical state. boiling and freezing points. Remember, I told you that when a substance goes from a solid to a liquid to a gas, it's all the same compound, or it's all the same substance, but it's a physical change. So those are physical properties. Density, the color of a substance, those are all physical. Chemical properties are only observed when a chemical reaction occurs, right? And these describe the ability of a substance to interact with other substances or change into new substances, right? And they also help us to describe the chemical composition, like how many atoms there are in a given compound, right? What is it made of? Or how does it react when it comes near another type of element? We can't necessarily measure a chemical property, but how do we know when a chemical reaction has actually occurred? Well, there are a few things that help you know a chemical reaction has occurred. A color change. And I don't mean it goes from a dark blue to a light blue. That is a dilution. That's a physical process. I'm talking about, let's say, a substance started off yellow and now it turns black. Or you have a clear or colorless substance that mixed with a white substance, and now you see, or two colorless substances, they mix together and now you see a white powder, right? Which is a precipitate. That doesn't really look too legible, but that says precipitate, right? Bubbles indicate that a gas has been released. When you see like a cloudy substance forming in a liquid, that represents a precipitate or a solid has formed. When the temperature changes, now the funny thing about temperature changes is that that can occur with a physical process or a chemical process. So it's not always an indication that a chemical reaction has occurred. On this slide here, we have some examples of physical and chemical properties of copper. You can pause the video to read through these. So what's the difference between a physical and a chemical change? A physical change occurs if there's, let's say, a change in the physical state, right? From liquid to solid, or solid to gas, from solid to liquid to gas, right? A change in the physical shape. So you have a letter that you receive someone that makes you angry and you tear it up into teeny tiny little pieces. It's still paper. Now, you can't necessarily put all the pieces back together unless you use some tape or glue, but it's still paper, right? There's no change in the identity and the composition of a substance. So remember that evaporation of water from seawater gives you crystal salts. And actually, seawater is made up of more than one salt, more than sodium chloride. There's a number of salts within seawater that's actually better for you than single salt sodium chloride. During a chemical change now, new substances form. So you have all the same atoms that you started with in a chemical process, but now they're all rearranged differently. Atoms that were chemically joined together are now separated, and maybe they're joined with other atoms that you started off with, right? These new substances have new chemical and physical properties. So flan, which is one of my favorite desserts, that caramel that you have on the flan was formed when you take sugar and you melt it in the pan, right? And so you can't get back crystalline sugar after you do that. You can pause the video and take a look at this slide to give you some example of physical and chemical changes. What are some chemical changes that you may have observed? All right, pause the video and answer these questions. And when you're ready to see if you got the right answers, start the video all over again. Are you ready? Classify each of the following processes as a physical or chemical. Ice melting in the sun. It actually melts into water and then evaporates into steam or water vapor. That is a physical process. That is a physical, it's a physical property, and it's actually a physical change. Copper is a shiny metal. That is a physical property. Paper can burn. Well, if I burn the paper, it changes into carbon dioxide and water. And so that would be a chemical property. A silver knife can tarnish. Tarnishing is when it turns like that black kind of color. It's actually when the silver reacts with oxygen and water in the air. So that is a chemical property. A magnet removes particles from a mixture. Well, the magnet doesn't change, neither do the particles, so that would be a physical process. How about classifying these processes as chemical or physical? Burning a candle. Well, because we're talking about burning the candle, it's different from melting, right? Melting would just be adding heat and then it melts, but the burning forms carbon dioxide and water, and so that is a chemical change. Again, ice melting on the street is a physical process. How about toasting a marshmallow? When marshmallow gets that charcoaly color on the outside, it can't go back to normal, can't go back to its original. That is a chemical process. How about slicing or cutting a pizza? That's physical. What about chewing pizza? That's physical. But if you chew long enough, you start to digest the um the starches in the bread, and then that becomes a chemical process. How about digesting the pizza? Yeah, that's a chemical process in your stomach, right? That's chemical process as well. Iron rusting on an old car. That as well is a chemical process.